Welcome to the Alice Springs Severe Weather Analysis for Wednesday, November 26, 2025. This morning's sounding was taken at 9 a.m. local time. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. This morning's sounding shows a challenging setup for convection. We have 142 joules per kilogram of mixed layer CAPE, which is quite marginal for Central Australia. The key issue here is the strong capping inversion, shown by that blue shaded area representing 162 joules per kilogram of convective inhibition. Notice how the mixed layer parcel path, that blue dashed line, struggles to break through the environmental temperature profile. The lifting condensation level sits at 790 meters above ground, which is relatively low and favorable, but without sufficient lift to overcome that strong cap, this energy remains locked beneath the lid. Wind shear is moderate at 15.3 meters per second through 6 kilometers, and the hodograph shows some low-level turning, giving us a supercell composite parameter of just 0.1. Storm mode is sub-convective due to insufficient CAPE. Now let's examine the afternoon transformation. The forecast maximum temperature of 38 degrees Celsius is expected to break through that cap, with a very high 95% probability. The enhanced plot shows us the difference between morning and afternoon potential. Notice the pink-shaded CAPE area has expanded dramatically compared to this morning, with the heated mixed layer parcel now achieving 1160 joules per kilogram. That orange heated parcel path rises much more freely through the unchanged morning environment. The blue shaded CIN has been eliminated, meaning the lid is expected to break. However, the lifting condensation level rises significantly to 2,866 meters above ground, which is quite high for organized severe weather. While the environment supports organized multicells or even supercells if storms can initiate, the elevated LCL reduces tornado and hail potential substantially. The significant tornado parameter remains near zero, and supercell composite is also near zero for the afternoon heated scenario. Looking ahead to tomorrow morning, the machine learning model forecasts a return to subconvective conditions. Mixed layer CAPE drops to just 13 joules per kilogram, with surface-based CAPE at 21 joules. Shear remains light at 12 meters per second. With virtually no buoyant energy available, the atmosphere will be stable with no thunderstorm potential. Tomorrow afternoon shows minimal improvement. The model forecasts only 36 joules per kilogram of mixed layer CAPE and 22 joules surface-based, even with daytime heating. Shear increases slightly to 13.1 meters per second, but this is far from sufficient. The lifting condensation level sits at 1,409 meters above ground. Storm mode remains subconvective with insufficient CAPE. Tornado threat is low, hail threat is none, and wind threat is none. Tomorrow appears to be a quiet day across Central Australia. The hodograph reveals a modest wind profile with 15.3 meters per second of deep layer shear. The wind vectors show backing and increasing with height through the lower levels, creating that curved appearance. The right mover storm motion vector points toward the south-southwest, meaning if supercells were to develop, they would track in that direction. We have 59 meters squared per second squared of storm relative helicity in the lowest kilometer, and 127 in the lowest 3 kilometers. While this provides some rotational potential, the combination with marginal CAPE keeps our significant tornado parameter at just 0.02. This is primarily a wind shear environment lacking the necessary fuel. The Brunt-Weissaler frequency profile, or n-squared profile, shows atmospheric stability characteristics. We see strong refractivity values exceeding 300 N units near the surface, indicating very stable air in the lowest levels. The elevated duct layer between about 701,000 meters corresponds to our observed surface inversion. Above that, refractivity decreases through the mid-levels, showing less stable air aloft. The superrefraction zone near 6,000 meters indicates another stable layer in the upper troposphere. This profile confirms why convective initiation is challenging today, with that strong near-surface stability acting as a formidable barrier. Bottom line for Alice Springs. Today features marginal CAPE with a strong cap that should break by afternoon, but elevated cloud bases limit severe weather potential. Tomorrow looks quiet with subconvective conditions. Always consult the Bureau of Meteorology for official warnings and forecasts. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.